Okay, so up until now, we haven't really worked with anything where we have a negative under a radical. So this is where an imaginary number is going to come in. So whenever you have a negative underneath a radical, that is actually equal to negative, or sorry, to I. So I is our letter that we use for an imaginary number. So I is an imaginary number. So for our examples, so we know that 4 is a perfect square, so we can break this up so that we just have the square root of negative 1 times the square root of 4. And that's going to give us, we have this is I and this is 2. So we would just have 2I. So whenever you see a negative, it's best to just break that negative 1 away and then keep the other radical positive. So we know the square root of 100 is 10, and the square root of negative 1 is I, so our answer would be 10I. And then for the last one, we can also skip that writing it out step if you recognize that the square root of 49 is 7, and the square root of negative 1 is I. So you don't have to write it out if you recognize that from the beginning. All right, so when combined with a real number counterpart, it is known as a complex number. The standard form of these is a plus bi. So a and b are your real numbers, and I is our imaginary number. And you can see the example right there. So let's simplify some more radicals. So for number 1, we know 9 is a perfect square. So we can break this up to be the negative 1 square root of 9, and then just take them each separately. So we'd have 3I. So same thing with 18. So let's break it up. So we have square root of negative 1 and square root of 18. So 18 is not a perfect square, but we can go ahead and break it down. Remember our two ways to do this, where we can either look for our largest perfect square, or we can break down 18 all the way down to its prime factorization. I'm going to go ahead and break this up to square root of 9 and square root of 2, because 18 divided by 9 is 2. So our answer for that would be this. We would have 3, because the square root of 9 is 3. The square root of negative 1 is I. And then we would still have the square root of 2 left over. All right, so now we're getting into complex number territory because we have this plus here. But we're still going to follow the same steps we've just done. So I'm going to actually just write this above. So we have negative 25. So I'm going to break it up to negative 1 and 25. So that would be 5I, because the square root of 25 is 5. And then we have plus 7. There's nothing we can do to add those together because they're not like terms, so that would just be our final answer. And we're going to do the same type of thing for number 4. So we would have square root of negative 1 times square root of 50. And 50 is not a perfect square, so we're just going to go ahead and break that down how we can. So I'm going to break it up to be square root of 25 and square root of 2. So that's a lot of like side work. So we're going to say this is gone, and we broke it up to be these over here. The square root of 25 is 5. The square root of negative 1 is I. And we just have a square root of 2 left over. So we would have 5I square root 2 minus 3 as our final answer. Okay? So that's pretty straightforward. Just whenever you see a negative, know that means we got to pull out an I. So our powers of I, so we need to know how to write really high powers of I. So they always repeat every fourth power. So I to the 1 is just I squared is negative 1, I cubed is negative I, and I to the 4th is 1. So one way to remember this is just to say I won, negative sandwich. And what that means is, and what I always do is I always write this out. So I always know it's I won, and it's a negative sandwich. So the negatives go in the middle. So it just rotates. So you can kind of count like I to the 5th power would be 1, 2, 3, 4, 5. So it's going to pop right back up to that I. So that's the same thing as just I. And it's going to keep rotating. So for 6, it's going to go to negative 1. For 7, it's going to go to negative I. For 8, it's going to go to 1. I to the 9. So if you're like completely stuck on this, you can write this out up here and go 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 would end up on I, and so we would have just I. I to the 10 would be negative 1. I to the 11 would be negative I, and I to the 12th would be 1. So see, it just goes through those, it repeats over and over and over again. All right, so we're going to simplify the following. So these numbers are going to be way bigger. So an efficient way to change the power of I to simplest form is to divide the exponent by 4, because we know it's going to repeat every 4th power, and look at the decimal. So let's go back up to our table. If we divide 1 by 4, we're going to end up with 0.25. If we divide 2, we're going to end up with 0.5. If we divide 3, we're going to end up with 0.75. And if we divide 4 by 4, we're going to end up with 1.0. So all we're really worried about is what our decimal is. So if we look at 14, so if we look at this first example here, if we divide 14 by 4, we have 3, so 14 by 4 equals 3.5. So all I'm worried about is this 0.5. So because it ends in a 0.5, that's going to tell us that it's going to be negative 1 based on our chart above. So this would be negative 1. All right, so going back to the same steps as before. So now we have 15. Let's do 15 divided by 4. 15 divided by 4 is going to be 3.75. And remember, we're only worried about that decimal. So we have 0.75. Up on our table, 0.75 is negative I. All right, 27. 27 divided by 4. 27 divided by 4 is 6.75. So we have 0.75 again. That means we just have negative I again. 55 now. 55 divided by 4 is going to give us 13.75. So again, we end in that 0.75. 0.75, so that's going to give us negative I. And then again, 101 divided by 4. 101 divided by 4. So we're just dividing the exponents by 4. We get 25.25. So we are only worried about that decimal. 0.25 tells us that we have just I. Okay? All right, so we also need to know how to simplify expressions that are in or that already have I. So we're going to follow the same steps. We want to rewrite our I's for number 1 so that they're all like in their most basic form. Also, we're going to treat I like a variable whenever we're adding it. So if something has an I, you can only add it to something else that also has an I. So for this first one, I'm going to do each of these separately. So we have 13 divided by 4. So I'm going to do 13 divided by 4. That's 3.25. And since it's 3.25, I'm going to go ahead and write my I1 negative sandwich. So 0.25 would be I. Next, we have 23 divided by 4. That is going to be 5.75. So 5.75 would be negative I. So we have minus I. And then we're going to do 40 divided by 4. So 40 divided by 4, we know that is 10. So there's no decimal on that. So that means that we just end up with 1. And what's going to happen is these i's are actually going to cancel out because I minus I is 0, and we're just left with 1. All right, so let's go ahead and do number 2. We have 2I times negative 4I squared. So let's go ahead and distribute that squared first. So we have 2I on the outside times, and we're going to do negative 4 squared. Don't forget that negative 4 squared should be a positive number, and that's going to be positive 16. And then we're going to have I squared. All right, and then we're just going to distribute it in. So 2 times 16 is going to be 32. And then we have I times I squared, so we add those exponents. So we have 1 plus 2 is 3. And looking at our I1 negative sandwich, I cubed is going to give us negative I. So this is going to be negative 32I. All right, now we're going to do where we add and subtract. So if we look at this, we have a negative. So let's go ahead and distribute that. So the first one stays the same. We have negative times negative 4. That's going to be plus 4. And then distribute that, and it's going to be minus 4I. And then we're going to combine like terms. So like terms are 5, just a normal number, plus 4. So that would be 9. And then anything that has an I, so negative 3I minus 4I is going to be negative 7I. All right, same thing for number 4, but now we already have a plus between, so we don't have to worry about distributing anything. So we have 3 minus 6I plus 1 plus 2I. And you can already go ahead and add. You don't have to write this out like that. All right, so we're going to combine like terms. So our normal numbers, we have 3 plus 1, so that would be 4. And then we have negative 6I plus 2I. So negative 6 plus 2 is negative 4I. And that would be our final answer. All right, next one, we're going to distribute in the negative 3I. So negative 3 times 5 is negative 15I. And then negative 3 times negative 7 is plus 21. And then we're going to have I times I, which is I squared. And then we need to make sure that if we ever have an exponent on the I, we switch it. So I squared is going to be negative 1. So we're going to have negative 15I. This is negative 1. So we have minus 21. Because 21 times negative 1 is negative 21. All right, 6, we're going to distribute the 4I in. So we have 4I plus 4I squared. And then distribute the 3 in. So we have plus 18 minus 6I. All right, so let's switch this out first. So we're just carry down the other things. I squared is negative 1. So we're going to have minus 4 plus 18 minus 6I. And then we're just going to combine like terms. So we have negative 4 plus 18. So that's going to be 14. And then we have our I term. So we have 4I minus 6I. So it would be minus 2I. All right, so now we have two binomials being multiplied together. So this is where we have to FOIL. So remember, this is first, outer, inner, last, or just make sure you multiply everything. So I'm going to do 2 times 4. That's going to be 8. 2 times negative 3i is going to be negative 6i. I times 4 is going to be plus 4i. And then I times negative 3i is going to be negative 3i squared. All right, I squared is negative 1. So this is going to change to positive 3. So we're going to have 8 minus 6i plus 4i plus 3. And then we just combine like terms like we've done before. So we have 8 plus 3 is 11. And then we have negative 6i plus 4i, which would be minus 2i. All right, and last one, we have the same exact thing. We have 3 times 8, which is going to be 24. 3 times negative I, which will be negative 3i. 5i times 8 is going to be 40i. And 5i times negative I is going to be negative 5i squared. So this is just going to be plus 5. And then we can combine like terms. So we have 24 plus 5 is 29. And then we have negative 3i plus 40i, so that would be plus 37i. All right, so go ahead and try some on your own, check your key, and then you are good to do your practice.